After my little introduction about the fluidized bed combustion technology, which is actually in addition to the information you received from the lectures about this combustion techniques inside our course, now we will jump into the laboratory exercise itself, and let me describe the objectives of the lab. And as I said, in the fluidized bed reactor, so you have the sand bed bubbling, and also combustion happens inside the bed. So, and the heat is released into the bed, and we need to utilize this heat into the process. So we have steam, we have pipes carrying water immersed into that to extract heat from the bed. So what is important here is to see how the heat transfer works inside the bed. So under what fluidization conditions we get the better heat transfer to extract heat from bed into the working fluid. That is the main objective of the lab. And also we will see how the pressure loss across the bed and also across the filters behaves under different fluidization conditions. Now we will see the components of the lab equipment here. So this is the fluidized bed reactor, the simulator here, and these two are the rotometers to measure the airflow which is going into the fluidized bed reactor. So we can control airflow by controlling this knob here, and I can vary the flow by adjusting this into the certain levels, and also I can measure the flow in cubic meters per hour rate. So we will talk about measurements later in the presentation. And the next measurement will be the pressure drop across the bed and as well as the filter. The filter is placed in here. So we have two pressure taps here, and the one is movable, the other one, this is the one of the pressure taps, the second one is fixed, which is placed underneath, under the at the bottom of the fluidized bed. So this one is movable. So when I want to measure the pressure drop across the bed only, so I insert this into the bed. That means bypassing the filter. And the pressure difference I can read through this U-tube barometer, where we have the water as a liquid, and this difference will give the pressure drop, corresponding pressure drop across the bed. And when I want to measure the pressure drop across the bed plus the filter, so what I do is I take this pressure tap off, and then I close the hole here, and then I read the pressure drop across the bed plus the filter. And when I want to measure the pressure drop across the filter itself, I just subtract two readings. And then we need to measure temperatures as well, and we have 4 temperature sensors placed in the equipment. And the first one is to measure the incoming air temperature, and second one is to measure the bed temperature, and third one is to measure the heater or the pipe surface temperature, and the fourth one also placed on the pipe surface and is connected to the heater guard, which protects the heater from overheating possibilities. And temperatures are measured by the thermocouple arrangement. So the first thermocouple is placed here. The second thermocouple is this one, which is movable. Then we can place in the different places where we want to measure the temperature. When you are using thermocouple, the temperature sensor is the tip of the thermocouple. So you have to place the tip at the right position where you want to measure the temperature. And the third and fourth thermocouples are welded onto the pipe surface, so you cannot see at the moment, but when you are in the third part of the exercise, you will take the heat element out, and then that time you can see it. And to read these temperatures, we have only one display. So the first one is the temperature at the inlet to the reactor. So you press number 1 here, and then you read the temperature here. And the second one is the temperature from this thermocouple, where you use this one is used to measure the temperature on the bed and also at the different places depending on the experiment conditions. So you to get the reading from the second one, you press number 2 here, and then you read the temperature coming, the reading coming from the second thermocouple. And the third one is the thermocouple welded on the pipe surface. When you press 3, so you read the surface temperature here. And the 4 is also the same, and that is connected to the temperature protection guard of the heater. And so we have airflow measurements, we have pressure loss measurements, we have temperature measurements, and the last set of measurements are about the power. So since we are not releasing power or heat by combustion, we are having heat transfer due to the heat produced inside the pipe electrically, and so we need to find out how much power is liberated to the sand bed. So we measure the voltage and current which is given to the electrical heater, and by taking those measurements we can calculate the electrical power which is transferred out from the pipe as a heat to the bed. And the voltage is read by this the voltmeter here without using this one for practical reason, and the ampere or the current to the heater can be read from this ammeter.